Happy Wednesday. It's, what we call in school, if you actually were here, it's called Hump Day. So just make sure you guys are enjoying the week. Just spend time with family, but, just do the work that we have for you. Don't get behind. This week is the start of quarter 4. Okay, so whatever you hear, I don't care if they say, are we going 3 weeks or we're going to be out 4 weeks, just keep doing what you're doing at home. Okay, you're still learning. That's the most important thing. Teachers, educators, all of us want you to do is learn. So just don't get down. Don't be like, hey, are they having state testing? Okay, don't worry about that because us teachers are not. We want to make sure that you guys are able to do and learn exactly what we want you to be able to do when you're at your house versus at school, okay? So yesterday we looked at lesson 19. I thought it was a pretty easy lesson. You guys tell me. Maybe you guys can give me a couple comments. Maybe we'll do a live feed at the end of the week. But, okay, now we're looking into lesson 20. It's the same kind of thing we did yesterday, except if you look today, we are not just adding and subtracting. What we're doing is we are multiplying and dividing, your guys' favorite things to do. So if I look at this, same kind of thing though, same thing, same concept, except now just remember, okay, now we're doing multiplication, we're doing division. So it says the farmer's market is selling bags of apples. So in every bag, there are 3 apples. So if you look, it was pretty hard. So I gave you the first one. It says if there's 1 bag, there's 3 apples. So remember, we're multiplying here. So I'm thinking about how am I going from bags to get to my apples, okay? And if I do that, you want to think, okay, I'm not adding 2 every time. Okay, you want to think about, okay, what am I doing? Well, the multiplicative structure, what I would say is instead of adding, I'm multiplying by 3. Because if I have 1 bag, I have 3 apples. If I have 2 bags, I multiply by 3. 2 times 3 is 6 apples. Okay, so then now I have 3 bags. 3 times 3 is 9 apples. So 4 bags, so 4 times the 3 apples in each bag would be 12 apples. So now this is where we get a little confused. It says B. Well, B is not a number, but B represents bags. So B is bags. Sorry, it's being all weird and moving around. So B equals bags. So if I have B bags and I multiply that by 3, think about it. You have 3B, or you could say, because I know you guys love to, 3 times B. But really I want you to understand this is the one I want you to go to. So we're multiplying by 3. Now I could ask you, hey, I gave you the total number of apples. You're like, what in the world do I do? Well, if I'm going from bags to apples, you multiply by 3. But what if I go from apples to bags? I don't multiply by 3. That does not make sense. You're doing the opposite. So the inverse would be dividing by 3. So now that we have the table filled in, let's look at B. What if the market had 25 bags of apples to sell? How many apples is it in all? So think about what you're doing. I have 25 bags. Times, how many apples are in each bag? Bam, 3. So 25 times 3 gives me, good, yes, exactly, 75 total apples. Okay, so now we go to the next one. If a truck driver arrived that had some A, we're going to call A apples because we're not really exactly sure what it is, then how many bags would the clerks use to bag up these apples? Well, did I give you a number? No, I gave you a letter. Okay, so what you want to think about is I'm just saying in general, how many bags would we use? Well, to figure that out, I would take my apples, A, divided by how many apples are in each bag? Well, we said 3. So instead of, this is where I told you right here, Okay, instead of multiplying by 3, that wouldn't make sense for the number of bags. To figure it out, you have to divide by 3, and then that'll give me my number of bags. So this is where we're working backwards. Okay, so you got to remember, my table doesn't just always go from bags to apples. My table can also go from apples to bags, which is what we did in C. So now I give you a nice pretty number. It says if a truck driver arrived that had 600 apples on it. So we're going from total apples now. How many bags would the clerks use to bag up those apples? So we're taking the information from C and understanding how to now plug in a number and use it for D. So I start with my 600 apples. Divided by how many apples are in each bag? It was 3. So then 600 divided by 3, well, I know 6 divided by 3 is 2, and then I add my 2 zeros, so it would be a whopping 200 bags. I don't know about you, but I do not want to take all of those bags off a truck. Maybe you guys are stronger than I am, but I'm not sure. Maybe a couple. Okay, so we're taking that information, we're finding how to find the multiplicative, the dividend structure of how we're dividing or we're multiplying. Okay, remember, they're always opposite. If I go one way, I can go the other way backwards using opposite, which would be division. So I'm going to do, let's see, you have 3 exercises, exercise 1, exercise 2, and then you have a challenge problem, okay? So I'm going to do a little bit of exercise 1, leave exercise 2 to you guys sitting on your couches while I'm not. I'm sitting at my desk, jealous. So then I'll go work to the challenge problem just a little bit. So in New York State, there is a 5-cent deposit on all carbonated beverage cans and bottles. When you return the empty can or bottle, you get the 5 cents back. Okay, so if I return 1 can, think about how much money I'll get back. I know it doesn't seem like a lot, but it could add up because it's something easy to do and good for the environment. So going from here, cans to amount returned. Okay, my refund money goes back in my pocket. Well, if I turn in 1 can, think about what 5 cents is as a decimal. See if you guys say it. Okay, it's 0.05. It's not 0.5. That's 50 cents. That would be crazy. Okay, they would lose a lot of money. So 5 cents per return. So if I have 2 cans I return, okay, I would have 10 cents. If I have 3 cans, I would have 15 cents. Keep adding 5. So you could say, oh, well, it's additive structure. No. I understand that you could look here and you could say, okay, I'm adding 5 cents every single time. Well, cool. You can go create the world's biggest whiteboard and then make a huge, huge, huge table for this one down here because it's not always true. Okay, it's not always true. Maybe for the first couple, but then you have to think about this. I'm multiplying, I'm multiplying by 0.05, 5 cents to figure it out. So if I have 4 cans, 4 times 0.05 times 4, you guys are making fun of me, but I'm just showing you that you could do this. Well, I get 0, I carry my 2. 4 times 0 is 0, plus 2 is 2. Well, I have 2 decimal place values, so I swoop it twice, and I have 20 cents. Now, this is where it's not as easy. I can't just add 5 cents like you guys were thinking you could here. Now it's 10 cans. Get it? 10 cans. So 10 times 0.05. So 10 times 0.05, you get 0. You get 5. Super decimal twice. And you get 50 cents. So now 50 times 5. So think about it. 50 times 5. Add the 2 decimal place values. I get $2.50. So then I take $2.50. See? There's enough for a Diet Coke and a McDonald's at your local West Milton, okay, which is closed down except for the drive-thru. But if I look here, I take 100 now, 100 times 0.05. Well, think about it. If I'm multiplying 100, I'm going to sneeze. No, I don't have coronavirus. False alarm. Times 0.05. Well, I swoop my decimal twice. 1, 2. Now I have $5. Look, that's 5 double cheeseburgers or whatever you want, or a foot-long sub from Subway. Okay, so I filled in part of the table, but here we get this weird thing. C, okay, stands for the word container, okay, or you can say cans, whatever you want to say. But how am I going from C to get to the amount of money that I would get? Well, I'm taking the C, cans or containers or bottles, whatever you want to say, times 0.05, which you guys like to write like that. I like to write it like this, 0.05 C, which tells me I multiply by 0.05. Okay, so I think I kind of just gave you the next one. If I look at B, if we let C represent the number of cans, what is the expression that shows how much money we'll get? Well, I just told you. It is C times 0.05, or, big boy, you could say 0.05 C. That's the expression. No equal sign because it's an expression. Now it says use the expression we just came up with to find out how much money Brett, whoever Brett is, would receive if we return 222 cans. Okay, this is why we come up with a multiplicative structure. Because if I keep adding and adding and adding and adding, okay, remember, I don't like to repeatedly add, I like to multiply. So then what we would do is we would substitute. We take C times 0.05. Now I know what C stands for, so it's 222 times 0.05. Okay, get your calculators out if you don't have them out. Okay, see if you can beat me to it. But it is 222 cans times 0.05 gives you $11.10. Pretty good. We're getting above the $10 mark. Okay, it adds up. It's something easy to do. So, now we look at my boy Gavin. So Gavin needs to return $4.50 in cans. How many cans does he need to collect? Well, that sounds weird. Because here I knew the cans and I wanted to find out the money, but now I know how much money it is. I need to figure out the cans. So this is why you need to understand to work backwards. You take the dollars, not times, but divided by 0.05, and then that will tell you the cans. So if I take the dollars divided by my cans, how much it costs per can, I'll figure out my total cans. So then use your calculator, $4.50 divided by 0.05. Wow. You would have to return 90, not containers, containers, to be able to get $4.50 back. Okay. So you try this one. Use this information right here to help you fill in this table. Okay, so that one's on your own. Answer those questions. Now I look at the challenge. So, a pendulum. So a pendulum swings through a certain number of cycles in a given time. Owen made a pendulum that swings 12 times every 15 seconds. Construct a table showing the number of cycles through which a pendulum swings. Include data for up to 1 minute. Use the last row for C cycles and write an expression to show the time it takes for the pendulum to make C cycles. So I'm going to write it how they have it. So 12 swings, not sings. You do not want me to sing. Okay, so if I have 12 swings, so I'm going to make this side swings. I'm going to make this side seconds. So if you look at that, I have 12 swings for 15 seconds. I have 24, that's 12, 24 swings for 30 seconds. I have 36 swings for 45 seconds. And I have 48 swings for 60 seconds. So now this is where you have to think. I have that last row saved. Okay. Remember, 60 seconds equals 1 minute. So I'm good. So how can I figure out? It says use the last row C cycles and write an expression for the time it takes for the pendulum to make C cycles. So this is where you're like, I don't know. It's not really clear. Okay. Do you add 3? Do you add 6? Do I multiply by 3? Do I divide by 2? Okay. You kind of have to think about it. So we might have to come back to that. If I look at it, okay, it's not as easy, clear cut as we have it. So if I see this, it's not that easy to see. So that's why it's a challenge problem. So I want you to think about the equation, think about the expression. How could I figure that out for this? Maybe you're going to get the answer before I do. Okay, maybe you guys are like, Mr. Mefford, just give me the answer. Okay, that's not how it works. Okay, I want to see if you guys can also do it. So, is there a clear answer? Probably. But probably not. So I'm going to make this C because really the swings stands for cycles. Okay. Now I have to multiply and divide. So that's why it was a challenge. You're going to take 15 seconds times the cycles divided by 12. So it's not just one step now, it's 2. Because I'm taking my 15 seconds times C, and then I'm going to divide it by 12. So let's see if we can get a right answer here. Okay, so Owen and his pendulum team set their pendulum to motion and counted 16 cycles. What was the elapsed time? So this is going to be my time. So if I know, okay, so it's 15 times C divided by 12. Well, I know, so 15, so I found my C. Here's my C. So 15 times 16 divided by 12. Order of operations, kiddos. What's 15 times 16? Well, that's 240. No, I did not just use a calculator. Okay, maybe I did. And then I'm going to divide that by 12. 240 divided by 12 gives you the whopping answer of 20 seconds. Okay, so see if you can do that. Okay, if I look here, write an expression for the number of cycles a pendulum swings in S seconds. So the number of cycles swings in S seconds. So now we're working backwards. Now we're working this way. Some of you are like, I quit. I don't want to do this. Well, don't worry. I'm here to help you. Okay? So if I work backwards, it's kind of like the opposite what I'm trying to do. Okay, so instead of taking 15 times C, I'm actually going to write it as a fraction, and I'm going to flip-flop it because, remember, order of operations, I can flip-flop. So it's going to be 12 over 15 times C equals S. Because this is just like a ratio, 12 to 15. Just like they stated up here, 12 swings every 15 go back to quarter one. Ratio. Working the opposite, let's flip the order. Okay? So now if I use that, it says in a different experiment, Owen and his pendulum team counted the number of cycles of the pendulum for 35 seconds. So I know my time. Right here. Okay? Just kidding. I'm fired. It's not C. I need to flip-flop these. That needs to be S. That needs to be C. That'll tell me my cycles. So then I take the fraction, your favorite, 12 over 15 times, let's write it as a fraction, 35 over 1. Do not keep change flip it because I'm multiplying. Equals my cycles. So does anybody know what 12 times 35 is? Steve, do you know? Oh, it's 420. So then I go and I write 420 over 15. Anybody know what 420 divided by 15 is? 28. So it'd be 28 cycles. Sorry, Mr. Murphy can't spell. So that was a more difficult one. See if you can do it. See if you can show me how to do it. Okay. If you look down here, this is where you're going to come up with an expression. See if you can answer these questions. Do not get stumped. Okay, some of them are pretty easy. Okay, let's see how well you can do it. Okay, so if you look here, there's quite a few on this. This is going to be a little longer. Okay, on this one, there's no problem set. Okay, it's kind of like all just merged into the lesson. So listen very carefully. You can skip this too. I'll put an X. Do not do question 7. Do not do question 8. Saving you some time. Okay. What I want you to do is send me a picture. Hopefully you're watching the video. Number 6 is your problem set. Number 6 is your problem set. Send me a picture of number 6. Send me the picture of number 6. Hopefully you're watching this. Okay, if you're having problems, I'm here to help you. I will post the answers tomorrow. Once again, have a tremendous day. Go outside, be crazy.